All right, so in these problems, one of the things you need to recognize is that you're dealing with a derivative, right? They give you the graph not of the function, but the derivative, right? So we're talking about speed here, velocity. Because we're talking about velocity, you need to be aware that there is no, you can't just look at the graph and describe things like concavity and second derivatives. You have to realize, wait a second, I'm looking at the wrong thing. So if I have the derivative, right, in this case with respect to time, then I can read the graph for speed, right? If I want to know distance or displacement, I have to do area underneath the curve. And if I want to find acceleration, or the rate at which the rate is changing, I need to look at the slope of my derivative graph, right? All right, because that's how you take the derivative of a graph. So I take a look at this and go, A, it says, what's the acceleration of Karen's bicycle during this at 7.5 minutes? Indicate units of measure. So I go to 7.5. That looks like it's right about here on my picture. And so we are going from 0.3. So we're going to 0.2 minus 0.3, those over 8 minus 7. Now, again, I didn't use 7.5, but it's on the same line, right? So therefore, the slope is the same there as it is everywhere else. Do a little mathage, I get negative 0.1 over 1, or negative 0.190 units. I go back and look at my units, and they're talking about what? They're talking about miles per minute and minutes, right? So this is going to be miles per minute squared. All right? And so that's how you're going to do the very first problem. Let's do B now. All right, B says, using correct units, explain the meaning of the integral of the velocity in terms of Karen's trip. Find the value of that. Now, here's part that's interesting. It says absolute value. Why? Well, because Karen, for a little while, does something strange. If you think about her trip, she starts bicycling one way for a while, covers some distance, then for some reason slows down to a stop, right? She stopped there. Then she starts bicycling the other way until she gets back to where she started. Because the area here is the area here. She basically left her house, went, this is kind of fun, got to a certain point, went, oh, I forgot my backpack. And then she turned around, went right back. And then she realized that she spent some time at home looking for her backpack. She got it. When she got it back on her bicycle. And then she panicked, so she rode really faster. And when her top speed, saw an officer, slowed down a little bit. Top speed for a while, and then slowed down to a stop when she got to the drug deal or whatever we're saying she went to. Okay, so Karen. Oh, the problem's down here. We could just read the problem. She's going to school. So she's not. So Karen's a good person. We're going to take back everything we just said about her because that's a bad thing. Let's talk about that. So here we go. Karen is, yeah, it's going to be that kind of day. All right. So Karen here. So found the acceleration rate. So now using correct units, explain what from 0 to 12 would be. Well, that's how far she rode, not the displacement, because when she rode back and forth, the absolute value bars say count this as positive, right? So all I'm going to do now is I'm going to find the area of the curve, counting this as positive. Now, if it asks for displacement, I would count this as negative, right? Because going backwards doesn't help me go farther away from the house. But going backwards and forwards counts when you're talking about how far she rode her bicycle. How far did she go? So now I'm going to go ahead and do that. I've got my, so the integral of v of t absolute value is going to be equal to the area underneath the curve. Then the area is going to be 1/2 2 times 0.2 plus 1/2 2 times 0.2 plus 1/2 1 times 0.3 plus 1 times 0.3 plus 0.2 times 3 plus 1/2 0.2 times 1. All right. So here we go. We're going to do some mathage. Oh, menu. Okay, so I've got 2 plus 0.2 plus 0.15 plus 0.3 plus 0.6 plus 0.1, and I get 1.55. Doesn't feel right. Hey, I skipped this. Oops. I skipped this little zone right here, which would be plus 1/2 0.1 times 1, little triangle on top, plus 0.2 times 1. And so that should give me another 0.25 to my 1.55, or 1.80. Any units? Using correct units, so that's miles. That's how far she rode her bicycle. All right. Shortly after leaving home, Karen realizes her calculus homework is at home. She returns to get it. At what time does she turn around and go back to home? Well, again, we described it right here. It's this point right here. So she's in 2 minutes into her trip. Well, wait a second, Ms. Dresney. It looks like she turns around and goes back here. Right. This is her slowing down. She doesn't turn around until her velocity is 0, so she can go back the other way. Or you got to stop before you turn around and go back. So at the 2-minute mark is when she turns around and goes back home. Okay, I'd write all that in a sentence and call it a day. Larry also rides his bicycle on a straight road from home to school in 12 minutes. All right. His velocity can model the following function, where WT is in miles per minute, 0 to 12 minutes. Who lives closer to school, Karen or Larry? Decided to work. Okay, so the only thing we have to worry about here is how do you figure out how far Larry's ridden his bicycle? The answer is the integral from 0 to 12 of pi over 15 sine pi over 12t dt. Now, to be frank, you can do this without a calculator, but who would? We've been taught how to do it with a calculator. There is zero reason to do it without a calculator. Make sure you're in radians. Your calculator doesn't freak out. I'm checking my radians right now. Shift setup. I'm in radians. I'm ready to go. So option, I'm going to put in calculator integral. I'm going to skip the pi over 15 because sometimes I freak out and do bad things with that. Pi divided by, it means lots of parentheses. Pi divided by 12 in parentheses x. Comma 0, comma 12 in parentheses. Boom. And I got syntax error, so that's even worse. Where's my syntax error? Oh, I need parentheses. There it is. And I got that he lives. Oh, I got a really big number, and they should be closer together, shouldn't they? Oh, I didn't do my, so I got to then multiply that by pi, divided by 15, and I get 1.6. Now, you're thinking, aha, he doesn't live as far away. But remember, she did something very strange. She rode, this first little bit, she rode away from her house and back. This part doesn't count, and that is 0.4 of her trip. So she's actually only lives 1.4 miles away. So they're trying to trick you here. He actually lives farther away. So Larry lives farther away. Karen rode farther to get there, but that's because she rode 0.2 miles away from her house and then had to ride all the way back. All right? Okay, that should do that problem. Hopefully it's all there for you. Boom.